Welcome to this third video on binomial distribution. So in this video we will see about the problem of particular category where we have a case with both a small n as well as capital N. So what is the small n and what is this capital N? We will look into it in detail. Say suppose there is going to be a class that consists of say 16 members. So this is going to be say ECA section. Now the total number of items which have to be investigated for is going to be n is equal to 60. Now in such case, if we are going to have many such sections A, B, C, D, E and F, all of which is going to contain some random number of n. So n is equal to 60, n equal to 4 and so on. So this entire of the quantity or the superset that consists of all these subsets will now be denoted by capital N. Capital N is going to be the individual entity. So if you are going to have say A, B, C, D, E, F, so 6 sections are there, then your capital N will be 6 and your small n will be equal to 60. Say in this case of matchboxes, we have individually a matchbox to consist of say 50 sticks. So how are these matchboxes packed? It is packed in a box of say 10. So you place 10 boxes and then wrap it in a brown cover and then they sell it. So in which case your capital N will be 10 and your small n will be equal to 50. So it always doesn't mean that small n is going to be very less in number and capital N is going to be bigger in number. It can be any way, but just get the context out of it. Now coming to the problem, we have out of 800 families with 4 children each, how many families would be expected to have 2 boys and 2 girls, at least 1 boy, at most 2 girls and children of both gender. Okay, so you are considering a big village kind of structure. So out of this village you have how many families? You have say 800 families. So you have 800 families and in each of these house you have 4 kids or 4 children each. So this is going to be your small n. So each family consisting of 4 kids, and then there are going to be totally how many families? 800 such families. So now this 800 becomes your capital N and your small n is going to be equal to 4. Now the problem as such doesn't have any keyword like use binomial or use Poisson to determine this probabilities. Now in which case how can we identify which distribution to apply for? We have been given 800 which is our capital N and each of this house has 4 children each. So our small n is going to be equal to 4. In this case, we notice that small n is going to be equal to 4 and this is going to be less than 20, a very small number. So whenever the number of trials is smaller in nature, then we will be applying binomial distribution. So now this n is equal to 20 is the keyword to choose your binomial distribution for application of this problem. In which case we have a family to have 4 children and out of the 4 some of them can be boys, some of them can be girls. So what is going to be a binomial distribution is probability of x equal to x is NCX p power x q power n minus x, which is valid for x varying from 0, 1, 2 up to n. And so what is our n? N is 4. So we have x varying as 0, 1, 2, 3 and 4. Now coming to fix these details, I already know that my n is equal to 4. N is equal to 4. Now talking about p and q, what is going to be p and q? So I need to fix my x. What is going to be x? X is going to be the action of either choosing a boy or a girl from a family. If we are not fixing this, then the problem will be almost toppling, because in certain problems they are asking for the probability of boys and certain problems they are asking for probability of girls. So to avoid all these ambiguities, let me fix that. Let x denote the number of boys in a family. So out of the 4, how many of them are boys? The number of boys is denoted by your random variable called as x. In which case, choosing a boy or selecting a boy is going to be termed as success. Okay, you choose a boy which is termed as success. So but the birth of a boy as well as a girl is going to be the same, and so without loss of generality we assume that choosing a boy is the same as choosing a girl, and so in which case this is the same as q. And so when you give equal chances to both a boy as well as a girl, so you give equal chances to both a boy as well as a girl, so you have this probability to be equal to half. So now our datas are all going to be fixed. So now we say that probability of x equal to x is 4cx. P we fix it as half to the power of x, and next half to the power of 4 minus x. Now observe the point over here, students. This is also half and this is also half. Base is the same, so you can club their powers, in which case this becomes 4cx half to the power of x plus 4 minus x. So we totally have this to be in a simplified form of 4cx half to the power of 4. So the only unknown variable to be input over here in the expression is just your x. So this can be easily fixed in your calculator with 4c, and the unknown variable can be gone for your alpha times, so it will become capital X. Choose the multiplication sign, go for half, which can be input as 0.5, and then you need to raise it power 4, so use the caret symbol and then press 4. So key in this using your computation mode in the calculator, and now we are ready for the calculation. So since this is going to be input, this can now replace wherever we have x by the corresponding value and then get us the answer. Moving on with the first subdivision. What is the first subdivision asking us? We want 2 boys and 2 girls. X stands for the number of boys. So what happens over here is, when I have the question of we want probability of 2 boys and 2 girls. So out of the 4, if 2 of them are going to be boy, automatically the remaining 2 are going to be girls for me. So this is nothing but probability of x equal to 2. So this is 4c2 half to the power of 4. So give the input of x as 2 and then you press equal to sign. You will get your answer for this, children. So please do check if the answer for your x equal to 2 is going to be equal to x equal to 0.375. So this is the probability that one family has 2 boys. Now how many such families are there? Therefore for 800 such families, the number of families with 2 boys will be equal to your capital N into probability of x. So this is 800 into the probability 0.375, which we have just now arrived at. So this gives the answer as 300. Now moving on to the next subdivision. We want the question to have at least one boy. So what does this mean? Probability of least greater than or equal to 1. So which case we can have 1 boy, 3 girl, 2 boy, 2 girl, 3 boy, 1 girl, or all the 4 to be equal to boy. Now computing this is nothing but probability x equal to 1. Computing this is probability x equal to 2. computing this is probability x equal to 3, and computing this is probability x equal to 4. You can compute them individually and then add the data so that you get the final answer. Or the other best way of doing it is go for the complement of it. So it is 1 minus probability of x strictly less than 1. What is the number strictly less than 1? That is nothing but probability of x equal to 0. So when we go for this, then probability of x equal to 0 will be equal to 0.0625. Subtract it from 1, and in which case what will happen, the total probability now turns out to be equal to 0.9375. This is the probability that one family has at least one boy. So for 800 such families, the number of families with at least one boy will be equal to capital N into probability of x. So this is 800 into 0.9375. So we have the answer to be equal to 750 families. Now moving on to the third question. The third question asks us that find the probability of at most 2 girls. The point to note over here is the question is about girls, but we have fixed the random variable for boys. So in which case we'll have to be very careful to convert the problem which has been asked in girls to boys. How can that be done? Just consider the complement of it. What will be the complement? Wherever you have at most, change it as at least. So when you change this at most as at least, then the 2 girls will become equal to 2 boys. So the probability of at most 2 girls is the same as probability of at least 2 boys. So what is the probability of at least 2 boys? 2 or more than 2 boys. So this will be 2 boys, 2 girls, 3 boys, 1 girl, or it can be all the 4 can be boys. So now this is the case that probability of x equal to 2, this is the probability of x equal to 3, and this is the case probability of x equal to 4. Or this can be otherwise handled as 1 minus probability of x strictly less than 2. So what are the cases here? Probability of x equal to 0 plus probability of x equal to 1 alone. So this gives me 1 minus probability of x equal to 0 is going to be 0.0625, and probability of x equal to 1 is 0.25. Add these two data and subtract from it, in which case you have the total probability to be equal to 0.6875. So this is for one family to have at most 2 girls. So there are for 800 families, so how many of it will contain at most 2 girls? So this will be capital N into corresponding probability. So it is 800 into 0.6875. So we have this to be equal to say 550 families. So out of the 800, 550 families have at most 2 girls. And last session, you need children of both gender. So it is the case that you need to have at least one boy as well as at least one girl. So at least one boy means you will have 3 girls, 2 boys, then it will be 2 girls, 3 boys, then it will be 1 girl. I cannot go for the other option 4 boys, in which case there will be 0 girl. You need to have both the gender in a family. So these are the 3 options. So I can go for this being probability of x equal to 1 because you have 1 boy, this being probability of x equal to 2 because it has 2 boys, and probability of x equal to 3. The other way round is 1 minus probability that all are boys or probability that all are girls. Then this will also tally all these 3 options. So this is 1 minus probability of all the boys are given by x equal to 4 and all of them are girls, means no boys, so this is 0. So you have it as 1 minus x equal to 4 is 0.0625 and this is going to be 0.0625 again. So subtracted, so the final answer will be 0.875. Therefore, for 800 such families, the number of families will be having children of both the gender will be equal to 800 into 0.875. So this turns out to be equal to 700 families.